The agenda is I will start with overview of the problem and the context, then existing system and technologies. Then I will move towards the system architecture and the algorithms we have proposed and implemented, then the hardware components and setup for the system implementation, proceed to the testing and results, and finally I will discuss about the conclusion and future work. Okay, so as you all of you know about the current scenario in Saudi Arabia, that in the there are a lot of marine pollution occurred mainly from petrochemical industries, oil spills, and sewage. So the impact of this untreated sewage, chemicals, and waste is huge on health and environment. There are many industries that are also the source of such pollution. So also the solutions are there for the treatment. So we have from the latest technological developments, Internet of Things is playing a huge role in improving the water quality monitoring, as well as to do some other tasks to improve the quality as well as the to manage such circumstances. So there is a need for IoT-based smart wireless water pollution detection systems overall. So this is the motivation for which we have worked on this area. So if we will look for the related work, then there are the use of wireless sensor network-based systems that are using sensors overall for the real-time monitoring. If we will look for the, again, from the networking domain, then the integration of ZigBee and LoRa, these are some advanced technologies to improve the transmission of the data from the premises to the monitoring location where the remote monitoring is going to be done. So these technologies are being embedding within the wireless sensor network-based systems. Nowadays, with the advancements in Internet of Things, where we have a lot of other equipments that can help the monitoring and management of the environment as well as the water quality. For the proposed methodology, you can see that here you can see the block diagram. So we have the IoT gateways. Those are for collecting the information from the areas where they have the contamination in the, you can say this marine, occurred by the marine pollution, as well as different types of sources we have tested for our experiments. Then we have collected these information throughout the from our sensors and stored them in the cloud. So we have used the cloud computing as well for the for later monitoring and for the storage. So that we have used we have actually implemented three algorithms for the whole purpose. Where we have monitored the key parameters related to the temperature, conductivity, and pH. With the as they have a direct relationship with one another. Okay. So, so we also have the mobile app where we have all these readings being displayed. We have done the data monitoring through sensors, through command line interfaces, and also through the Blink platform. So basically, this is the workflow for the water pollution detection system overall. First of all, the setup is being configured with the necessary working configurations. Then it is being connected to the LTE network. So this is the load transmission and evaluation. And then it is being connected to the Blink platform for all the observations to be communicated to the end users so that they can do some decision making according to the situation. Then operational signals have been sent to sensors. They have then they will receive the acknowledgement signals from sensors. Once the acknowledgement has been received, then the water pH level will be read, water temperature will be read, and these values and conductivity as well, these values will be calibrated and recorded for the next decisions, and notification will be sent to user. So if these values are there, then it means that the pollution has detected. If not, then the water is having a pure quality. And if there are no acknowledgement, then again, thus maybe the sensors are not getting any data. Okay, for the system implementation, these are the components that have been used. Microcontroller, GSM module, pH and temperature sensors, as well as we have used their libraries for the application programming interfaces. We have transmitted the data to Blink IoT platform, where real-time alerts has been collected via the GSM for immediate action. So this is the Blink platform, the interface on the Blink IoT web platform. Here you can see that with the help of the GSM, the current picture, the current location has been analyzed with the passage of time. So after some hours, after 2 hours, so we have collected these values for the water pH level. Here water temperature level has been recorded. So in this way, different so this is such a platform that can be used for the analysis of this type of information. And this is the interface of the mobile app. So we also have the interface that is the cloud-based application. So the same information can be delivered or notified to the end users to monitor all the situations on the go. So the same readings are there, and here the current GPS locations has been captured. For the hardware testing, we have performed different tests. So also, if I talk about the experimentation to conduct the quality, so we have performed 4 water sources were tested. So out of those 4 water sources, one was the tap water, one was the aquatic from the water from the aquarium with the fish inside it. One is the sea water, so that is the saline, you can say the salinity level was high. And one was the drinking water. So just, I didn't include that much details here because you know that we like for a short paper, conference paper, so we don't go for such details. So, but I can just explain it that according to the different levels that are being mentioned, for the conductivity of the water. If the conductivity is high, so it is not drinkable water. So then if we move towards the or sea water, so it has more conductivity. And even for the aquarium, the aquatic environment, the pH level, the conductivity level, they should be less. That is bearable for the aquatic environment or the animals to survive. So, so there are different these studies as well. So we have done, but for the short time, I didn't include it here. So this is just for the monitoring. So if I will conclude, so we have through this application and the real-time monitoring system, we have successfully monitored the water quality in real time and the detection of the pollution as respect to these 4 different sources of water. Accurately, the quality of the contaminants or chemical in the water has been detected with timely alerts, and notifications were sent to the end users. For the future work, our future directions are that we want to do some more analysis with the help of neural networks, and we will increase you can say the distance to monitor the real scenario. So for that, we will use the LoRa for remote sites. So these are the references. Thank you.
That's it.
Yeah, notifications will be, alerts will be generated through the app and it will be sent to the end user.
Mm. But you think as a people for pollution, temperature,
yes,
pH,
yes,
and
conductivity.
Yeah. So is this the common for all countries?
Yeah, we have selected 4 types of water to do the experiments.
It's salted.
Sea water.
Pure, natural.
Yeah.
So are you system focus the difference between 2 kinds of water? Yeah, so it
these different parameters has been set that if level is from this to this, so this is this type of water. And the level like from drinking water, the pH level should be from 6.1 to 8.9, for example. This is like the like we have pH water. Yes, yeah. For the experimentation, yes. We have the prototype, actually. It was the final year project of my students. So, but on the last moment, we couldn't arrange with the students. They couldn't come to present the whole, they have the prototype. Yes, they developed it. So they have like, they make a box with different types of water sources, and on the go in the class, they did the experimentation in front of the audience. Yeah.
So you want to
no, this is just laboratory work. Yeah, this is just the prototype and done in the laboratory. Yeah.
But you put some, I see, for presentation, you see the picture of the sea or something like that. Is your system also is applicable?
Yes, yes.
The sea and something like that?
Yes, yes, it is. It will be. We have recently submitted a proposal in RDIA for the second call. So where our next target, once we have this, so next target is to implement it on large scale.
But we will face another problem other countries, because we will have selected large number of sensors. So we will need to know the quality of the sensor which detects this.
Yes, yeah. So
it is the kind of protocol which lets the system know the sort of information from which sensor and so on.
Yeah.
Or just,
No, we have used the protocols as well. Yeah.
What's the detection?
For the
sea.
for the sea.
Yeah. Pollution is what is immediate action? Because system is a closed loop. Detecting and prevention as well.
No, not the prevention, it is just the detection.
Detection.
Yeah. So
Detecting action.
just to send the alerts, yeah, to send notification that this sort of the contamination has done in the water, in the area where they have these sensors installed. So then notifications will be sent. Yeah, this is just this at this step.
Very good. And push towards this inshallah.
Yeah, our next step is to consume the water as well. To consumption, water consumption. So on the basis of this as well.
Thank you for your presentation.
Welcome.
Very nice. I hope for something.
Yeah, inshallah.
Sure. Thank you.
Welcome.
Is anybody we will go to the paper entitled Warehouse Management and Tracking System for the University Asset using IoT technology to optimize the operation and reduce randomness. Salma Al-Haj, Bashair Al-Judi, Ola Al-Rifai, and Ikram Al-Hazmi. There is Ikram. Go ahead, Miss Ikram. Do you hear me, Miss Ikram?
Yes, I hear you, but I want to join the presentation.
You can share your presentation now.
Okay.
They will. Take it. This one? Oh, this is all. Go ahead, Miss Ikram. You hear me, Miss Ikram?
Hello?
Yes, I hear you, but there is a problem to share the presentation.
Right. Okay. Take your time.
Okay, thank you.
Screen, share
Sorry,
screen.
yeah.
What's the problem?
So
We tried to share the presentation, but we didn't know how to.
from where?
Just a moment. Let's start with you. Ikram. Yeah.
حتى أنا
Make host. Okay. Yes. It's okay. Ask the doctor.
The host asked you to start your video.
أيوة. سوي
The phone.
It's 20.
Yeah.
Excuse me? From where we can share the document?
from where you can share document.
Yes, we try to upload it.
But you can present, you are now you are a host now. You can display it on your computer and it would appear in my site here.
Okay, sharing screen.
Share your screen.
Okay, so share screen.
You are a host now.
Okay, thank you.
Yes.
Okay. Is it clear now?
Yes, okay, go ahead, inshallah.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah.
Ikram, you have 20 minutes, 15
Okay.
minutes for your presentation and 5 minutes for question.
Okay.
Go ahead, please.
I am Ikram Al-Hazmi and my colleagues Ala Al-Rifa'i. We will present our paper in this slide. First of all, we knowing that the assets management is a critical problem and challenge for a university. For those reasons, this project aim to design a robust warehouse management and tracking system using Internet of Things technology. First of all, the problem statement, lack of real-time tracking, assets tracking. It's a struggle to monitor assets location in real time. Then random movement of assets. Random movement of assets may cause losses or theft of our assets in university. Manual processes and human error. This is one of the problem may faced. This caused human error. Inefficient maintenance participant. Without structured tracking system, maintenance can reactive rather than become proactive, leading to unexpected breakdowns. Difficulty in assets accountability. This can poor tracking means resources are underutilized and overused. Both situation that the cost will increase for in assets resource allocation. Then we move to the objective of our paper, efficient asset tracking. Tracking assets in real time reduce error and improve resource allocation. Minimize assets loss and mismanagement. Well-managed system help to prevent assets losses. Automation of inventory management. Tracking system ensure responsibility at all levels. Enhance accountability. Our approach ensure long-term growth adaptability. Optimize maintenance scheduling. Achieving this goal led us to streamline operation, reduce cost, and ensure long-term success. Here we talk about the background and the literature review. We do it in our research paper. Highlight the key aspects of our approach. First approach, smart classroom architecture. We optimize learning process and techniques to facilitate classroom and university campus management. IoT and radio frequency identification for warehouse and classroom optimization. Real-time location monitoring in smart classroom, passive radio frequency identification, based system inventory and tracking. Optimizing educational environment through IoT integration. Promising solution to enhance classroom management and improve to operational efficiency. enhancing operational efficiency. This is the aspect we talk about in research paper. We categorize the literature review into this aspect. Next, we talk about the methodology with my colleagues Ala.
Here we can talk about the business process analysis using this diagram. In this diagram, show the cycle of steps to improve a business process. It starts with process identification, where we define which process we want to analyze. Next, we move to process discovery, where we collect information and understand how the process currently works. This is called as-is process model. After that, we do a process analysis where we define a weakness and problem in the current process. We study their impact to find area for improvement. Then we move to process redesign, where we create a new version of a process solving the issues found earlier. Once the redesign is complete, we process implementation, where we apply the new process in the real business environment. This creates a to-be process model. Finally, we have process monitoring and control, where we track performance and ensure everything is worked correctly. If needed, we make a further improvement, and cycle continues. This cycle helps business process become more efficient, reduce cost, and improve overall performance. Here, we can talk about the as-is process discovery for as-is for our project. The as-is scenario is an employee submit a new request by filling out a form that includes a name of the item, quantity, and description of it, which is forwarded to the warehouse keeper, where the warehouse keeper verifies the availability of the requested item manual. If the quantity and description match the request, the employee is informed that the item are ready for collecting. Upon receiving the item, the employee check them again manually to ensure that match the request. If if the keeper updated the database with the new quantity and descriptions manually. If there is a discrepancy, the process reverts to verifications. In case where the request item authorized person is for the item. Next, we're going to talk about the frequency warehouse check. We find explain. This slide will explain how frequently warehouse check case several major problem in our warehouse management. According to the 80-20 rules, 80% of the problem come from 20% of causes. In case frequently warehouse check are the key factor leading to delay response time, which is slower process and decision making. Efficiency facilitate management, which is resources are not used efficiently. Product information's error, make mistakes in tracking and managing inventory. The table and the chart show that frequently warehouse check is and product information error contribute the most to those issues together. They account for a major part of the problem. How to fix these issues? To solve this, we show reduce the number of necessarily check, improve accuracy and efficiency when checking. By doing this, we can minimize error, save time, and improve overall efficiency. Here, we make a YY diagram that help to find the root cause of the problem by asking why multiple times. The main issues here is frequently requests of checking. We ask why this happened and find two main reasons. Lack of regular updated in the database and lack of accuracy when adding item. For the lack of regular updates, we ask why again and find that staff is not well trained because of lack of a leadership support. There are conflicts with other tasks due to limited staff. For the lack of accuracy, we ask why and see that staff is incompatible because they do not have a clear task. Here, the measurement of a KPI according to the as-is model. The KPI performance to measure the efficiency of a warehouse operation based on the current process as is. The table highlight 4 main KPIs. A waiting time was take 7,200 seconds, which is kind of 2 hours. This represents how long item or task are delayed in the warehouse. A long waiting time suggests inefficiency in workflow, which can lead to slower operations and customer dissatisfaction. Error rate take 600 seconds. The amount of time lost due to mistakes in process like data entry or inventory tracking. High error rate indicate the need for process improvement and better accuracy in our warehouse operation. Rework rate take 600 seconds. The time spent correcting mistakes such as fixing incorrect shipment or updating inaccurate records. High rework rate increase operation cost and increase the operational cost and reduce our productivity. Here the process redesign after we add the process technique using the UHF radio frequency identification sensor. The scenario will be an employee submit a new request by filling out from the include name, item quantity, and etc., which then forwarded to a warehouse keeper. The warehouse keeper provides the availability of the request item automated using the Internet of Things technique. If the quantity and descriptions match the request, the employee is informed that the item is ready for collecting, open to receive the item. The employee check them again automatic using the Internet of Things technology to ensure that match the request. If the items are correct, the order is marked as received. The warehouse keeper updates the database with the new quantity and descriptions automatically. If there is discrepancy, the process reverse to a verification in case where the request item are invaluable, the authorized person is notified of the deficiency. Next, here we have a comparison KPIs between as is model and redesign. We find out the table show that improvement after redesign the process, a waiting time decreased from 700 to 7,200 seconds to 120 seconds, faster processing, error rate reduced from 600 seconds to 0 or no mistake, a rework rate drop from 600 seconds to 60 seconds, less correcting need. The new design make the process much faster, more accurate, and more efficiency. In conclusion, this project show how Internet of Things technology can improve the warehouse management. Universities, it help manage resources efficiency. It improve sustainability solutions tailored for education institution. University can adopt a new technology and improve our efficiency. Successful implementations of this project can serve as a model for other institutions. Overall, technology makes inventory management easier, faster, and more accuracy.
Now we will discuss the future work. First of all, scalability enhancement, improve the system to manage growing number of assets and user as university resources. Integration with existing system, connect our project with university finance, procurement, and HR system. Advanced analytics, use training and feedback, conduct training and gather user feedback to enhance the system usability, pilot testing and iterative improvement. Implement the system in phases, collect real-world data, and refine feature based on user feedback. Exploring techniques, development exploring, blockchain study for sure assets, and explore the reality address for process aware of the system. Thank you for listening.
Thank you very much for your presentation.
Thank you.
And now the time for question from that. Please return to the table which make comparison between the traditional system and the redesign.
KPIs?
Here.
Yeah, this is okay. This is okay.
Yes.
You are talking about error rate. What is the meaning of error rate 600 seconds?
The time take between correcting, sometimes the housekeeper or the employee enter maybe an accurate error, inaccurate items, number item, or he mistake by the description of the item. This is what we mean by error.
Ikram is talking?
No, Ala.
أنا. طيب آلاء يا آلاء الريت normally is measured by number of time error. For example, we can say مثلا 1% أو يعني something like that.
Okay,
أو
clear.
1 over 1,000, but it's not measured in seconds. This is my notes really.
Okay.
Waiting time is okay. Waiting rate is not measured by second, by the way. But also you are talking about scalability. It's okay. يعني معناها your system can cope with whatever the asset size, the system will perform in the same way. Is this correct?
Yes.
Okay.
Yes.
How do you achieve that? How to make your system scalable?
Easy to to add items because this technique or this radio frequency identification, it's easy to scalable because it it has no battery. It has no battery inside. It doesn't need battery, and it's still it's take long time or long duration time without needing battery.
How?
We find that UHS
Yeah, المفروض
is-
replica
إنه it's easy to scale.
replica of server or something like that. Normally, scalability as achieved by system can be extendable, expanded بالظبط كده.
Yes, we
يعني المفترض زي ما لو احنا if you want to the doctor 10 patient per day, the doctor will perform well. But if 100 patient want to the doctor in 1 hour, the doctor will not do well.
yes.
So how to make a system scalable? We have to bring another doctor, by the way.
Yeah.
Okay, thank you very much. I know that you are a student in IT department.
Yes.
That's okay.
شكرا.
But your presentation is very good. Thank you very much.
Thank you.
Now we will go to the next paper, comparative analysis of communication protocol in blockchain Internet of Things system for optimizing Internet of Things data flow efficiency.
Maybe the first one, I'm sorry.
First one?
Yeah.
Which one?
Yeah, but maybe the system has not. Yeah, it's here. Yeah, the green one, yeah. Hello, everyone. I don't think I need this. Okay, so I'm so glad to present this recent work under the title of Comparative Analysis of Communication Protocols and Blockchain IoT Systems for Optimizing the IoT Data Flow Efficiency. My name is Manara Naghes, and this is our recent work. I'll move now to the next slide to show you the outline of this presentation. So, is there like any, no, I think maybe this one.
Yeah.
So I'm going to talk about the overview of the research. I'm good. Yeah, maybe through here. Yeah, thank you very much. So I'm going to talk about the research overview. I'm going to share with you the contribution of this research. I'm going to talk about the challenges, the framework overview, and also I'm going to mention the methodology that we used here, the research evaluation, and then I'm going to conclude this work by mentioning some future ideas. So when I started my PhD journey, it was my first time to hear about the IoT. I was brand new, have no idea about it. So I had to read about it and educate myself. And I noticed that this kind of networks are getting like growing in very, very rapid way. So I thought like we need to find some solution for this growth or rapid growth.
because we face lots of challenges in terms of privacy, data integrity, and also security. So I also thought about why not explore the existing solutions that we have and then try to combine two different solutions together to find a new solution. So I came across the decentralized identifiers. Normally, we use it to provide the identity format for the IoT devices. And also the blockchain, which is widely used. I noticed that we have the ability to increase the security level by combine it with the cryptography, right? So I thought of like, why don't we use these two solutions together to build a new solution? So by using the DID, we will increase the trust among our users within the network, and also we will enhance the privacy for our users and also the network. And also we thought about which cryptography algorithm should we use. We found different algorithms, but we ended up with the elliptic curve digital signature algorithm because we thought or we claim that it's really efficient for security. It's going to be really useful for our work. So the contribution, we build a secure, distributed, scalable scheme using the DIDs and also the elliptic curve digital signature algorithm encryption, which will lead to enhancing the overall IoT security. So IoT systems, as we know, has too many different challenges. As I just mentioned a minute ago, privacy, we need to protect our sensitive data because, for example, if I use IoT systems in hospital, it's going to be very risky to not be able to save the privacy of our users. And also the data integrity, we need that to ensure that the authentic person is using his data, no one else. And also we need to manage this huge data or big data volume to make sure that we are going to perform our service in a very good manner. So I know that we have already established blockchain solutions to secure the transaction and also to efficient or make the security more efficient for users, but it still has some challenges in terms of users' privacy and also in terms of efficiency because it takes time for performing their job. So the objective of this work is to optimize the IoT data flow using a modified blockchain structure. So basically, we take the blockchain and also we take the IoT structure, we combine it together, and we have this framework here, sensing layer, which the layer that's responsible for collecting data, communication layer, which is responsible for transferring the data, blockchain hybrid, which is the processing layer. We change this layer or the processing layer to the blockchain hybrid layer. We use it for as a buffer for the data, just to make the process of the data much easier or like give us some room for the data to be analyzed before going to the last layer, which is the application layer for the decision making and also to perform the service. This is the picture of our framework here. As I mentioned earlier, the sensing layer where we have the IoT devices here, sensing the data, collecting them, and then move it to the next one, which is the communication layer through the gateways. And then we come to our proposed solution here, which is the processing layer. We replace it with the blockchain hybrid layer. It has sub-layers, as you see here, 5 layers. Data layer where we define the blockchain structure and also the data type. Network layer here where we manage the user access and validation. The next one, consensus layer, where we verify if the block is legitimate or not. And then the incentive layer where the user will be rewarded by for maintaining the block. And after that, the last one where the user will be able to execute the data and request the service. And after that, we will go to the upper layer, which is application layer, to perform the service that the user would like to do. Here, this section where the blockchain ID hash is, we combine it with the DID document here. We have 6 sections. We have the context where we define the protocol of the DID. And also the ID here, this is the unique identifier for the users. And the controller here, we will have the users of this blockchain, and we may have many than one. The public key, where we use actually the elliptic curve algorithm for verifying the ownership of the user that are sharing this blockchain. And the service here is like the issuer info with the service info information, and the authentication here where we present the certificate authority. So for the methodology, I think about which platform will be useful for us to do this work. And I choose MATLAB. The reason is just it's really handy to establish an environment from zero. It's like flexible. And also, I came across the cryptography existing data or function, which is the National Institute for Technology elliptic curve parameters, and also the elliptic curve cryptography for generating the data set of this work. For our network configuration, we had between 25 to 40 nodes, and the memory was 16 gigabyte. And as you see here, the transaction details we have, the standard size was 1 kilobyte. The TCP protocol was used for the transmission, and also the DID document size was 700 bytes, and this is the algorithm that we used inside the DID. So consensus algorithms, we have different types for these algorithms, but we choose the proof of work because it was easier for us to adjust it in order to optimize the consensus time. So that's why we choose it. And the key measurement of this work, we focused on the delay by focusing on the round trip time for delivering the message. And also we focused on the CPU and memory utilization. Like also the communication protocols are too many, so we choose these two protocols just because the MQTT optimized for real-time environment, and the COAP best for the low resources environments, which we are working with now. And we use for the evaluation the consensus time, the network throughput, and also the time taken to generate messages between 1,000 to 3,500 DID documents. And also the message was tested by the rate of between 10 to 5,000 messages per second, and the base load sizes was between, we started with 36 bytes and increased to 1,024 bytes. The throughput here, because we are focusing on low frequency data, the average throughput kind of acceptable here by having it in 59.70 kilobyte per second, and we use the remote procedure call over TCP. And for the comparison of these two protocols, we found that the COAP is more like useful for IoT devices when we focus on the low frequency data. And MQTT has a higher delay, but still efficient comparing with the other results, because we had another papers, we had another comparison inside the paper if you would like to have a look. The feature of our scheme, in short, device authentication Yes, we have device authentication. The blockchain type is private. Consensus type we have here is the proof of work because it's easier, and the security was high. The peer-to-peer encryption, yes, we have it inside the DID. The integrity was high, and data availability also was high. So the conclusion for this work, we noticed that by having the software test, because it's still software, we didn't test it in the real time. I mean, like in hardware, from hardware perspective, we still need to test it. Actually, we are testing it as like we speak. We are working on this side. So based on the software result, we noticed that our results are promising, and it's really going to be useful by combining these two solutions together. And inshallah, in future, we will be able to build something for real, like to be able to use it among the IoT devices. And for future work ideas, here we didn't focus on the heterogeneity of IoT. It wasn't like well explored here. So it could be one of the future work ideas, and also improve the adaptability of unreliable communication mediums, and also to test the integration of IoT and blockchain for border applications. If you would like to have this script of this work just for future testing or for future examination, or like to improve it more, please contact me through this email. I'm going to be happy to share it with you. And thank you for your time and listening.
They could work hard, and wish you all the best, really. But I have just a little. What's the problem which inspire you to suggest this solution in Germany? Refrigerator as well. يعني you can order eggs from the shop. Decentralized system normally suffer from thinking how to sync the data in the distributed system, because otherwise you will get inconsistency in the distributed system. So you need to sync between the different nodes in your system. How you do achieve that? Again, this problem. I don't ask for an answer, but also there is some, you using the RPC. Why you don't use remote method invocation, for example, the distributed object, rather than RPC? It's very not object oriented. RPC normally should be registered in some place. Yeah, RPC. Yeah. Yeah. Very good, Manat, and best wishes. We ask Allah to return to us. Salam alaikum wa barakatuh. Zaka doctor. To return a great doctor, inshallah, from. You hear me, Muhammad?
Okay, sir, may I start?
But your paper is not severe.
Sorry, sir, I couldn't hear you.
Just a moment.
Okay.
This is the previous one. Your share, please share your presentation, please.
Okay, thank you, sir.
It's not appear. It's not appear at us here.
Okay. So now, sir?
Not yet.
Okay.
Stop share and share again, Mohammed.
Okay, sir.
But I see it here. Enable it. Enable it. Oh, okay.
Sir, I am already shared. Are you?
Yeah. It's appear on my site. I
Okay,
will,
sir.
just a moment. Problem from here.
Okay, sir.
problem from here, yes.
Okay. So is it appearing?
Do you hear me?
Yes, sir.
Okay, go ahead.
Okay, thank you, sir.
Thank you.
Okay. Good morning, everyone. It is a pleasure to be here today to present our research on IoT-enabled smart air traffic control for drones in urban areas. It it is an AI-driven route optimization and energy management. Here is our authors. We are from the American International University, Bangladesh. We have proposed a system that aims to address the route optimization and energy management for drone. So wait a minute, I couldn't change my slide. Okay, here. Okay, so here is our outlines. I am start with introduction, then I discuss about the objectives, then then I discuss about the whole methodology, then I will show you our proposed framework, then rest of the options I discuss one by one. So okay, the rapid growth of UAVs has opened up new opportunities across various sectors, including transportation, delivery services, and emergency responses. However, as UAV means unmanned aerial vehicles, applications expand. Managing drone traffic in urban airspace has become increasingly challenging. Traditional air traffic control systems, designed primarily for manned aircraft, are struggling to meet the demand of this new fast-evolving landscape. These systems lack the scalability and adaptability required to handle the unique needs of drone optimization operations in dense urban environment. This gap underscored the need for a smart IoT-powered drone traffic control system that can manage the complexities of UAV operations, ensuring safe, efficient, and scalable integration into urban airspace. By leveraging IoT, drones can be monitored, coordinated, and controlled in real time, enabling a more flexible and responsive approach to urban airspace management. Okay, so our aim to develop an AI-driven IoT framework for drone traffic management to optimize drone routes using AI algorithms, to enhance energy efficiency with real-time battery monitoring, and to ensure safe and sustainable drone operations in urban areas. So here is a methodology. The methodology for the smart drone traffic control system revolves around a multi-layer IoT architecture designed to facilitate efficient communication, real-time monitoring, and decision making. As its core, a centralized AI-based system makes centralized decision regarding drone movements, ensuring safety and efficiency. Key parameters such as collisions avoidance, energy management, and route optimizations are tackled using advanced algorithms. Swarm intelligence technique like particle swarm optimization and ant colony optimizations are employed to prevent collisions, while IoT-based battery monitoring ensure optimal energy use and extends operational time. Real-time route optimization is achieved through the non-dominated sorting genetic algorithm. 2. Ensuring the drones take the most efficient paths. Additionally, sensor calibration plays a crucial role ensuring precise navigations and maintaining accurate geofacing, ensuring that drones stay within designated airspace boundaries. Okay. Calibration and validations process ensure the system's reliability, providing the foundation for safe and scalable drone traffic management. So here is the proposed pathways. So our proposed system drone cannot be going to the dense zone or high-rise building, just roaming in the safe zone like low buildings or not so dense area. Okay, so here I explained it how it does it going. The proposed system integrates advanced technologies to enable efficient airspace control and management. 3D geofencing is implemented to define precise vertical and horizontal boundaries for drone operations, ensuring safe navigations within designated airspace. AI-driven route optimization powered by particle swarm optimization and aircraft optimization dynamically calculates the best flight paths, avoiding obstacles and minimize flight time. And an energy management system utilizing IoT-based battery monitoring ensuring drones operate with optimal energy parameters, while solar integrations provides an additional power source to extend operational endurance. The communication system is designed with a multi-layer approach employing LoRa for long-range connectivity, Bluetooth for short-range interactions, and cloud processing to handle real-time data analysis, decision making, and monitoring. This combination technology creates a robust framework for efficient and safe drone air operations in urban airspace. Okay. The systems employs AI-powered swarm intelligence for collisions avoidance, enabling real-time adjustment to flight path based on drone interactions and environmental conditions. Energy optimizations in achieved through solar panels that recharge drones in flight, extending their operational range. Additionally, IoT-based energy monitoring allows the system to adapt route based on available battery power, ensuring efficient energy use. Ensuring efficient energy use throughout the flight. Adaptive airspace management is facilitated through 3D geofencing, which defines safe drones corridors, ensuring drone operate within designated boundaries and avoid unauthorized zones. Together, these technologies ensure safe, efficient, and sustainable drone operation in urban airspace. Okay, in the scenario, let's understand our proposed system with a hypothetical case study. In the scenario of medical supply delivery in a high-rise urban area, several challenges were encountered, including higher traffic, unexpected obstacles like buildings and other airborne issues. The system implemented AI-driven path correction to dynamically adjust the flight routes to ensure could drone could adapt their path based on their energy levels, preventing battery depletion during flights. Additionally, collision-free navigation was achieved by using particle swarm optimization and anchoring optimization, allowing drone to efficiently adjust their paths, avoid collisions, and maintain safe distance from other flying entities while ensuring safe and timely delivery. So here is our conclusion and future work. The impact of AI and IoT smart air traffic management is transformative, enabling real-time monitoring, efficient coordinate and decision making for drones operations in urban airspace. AI enhances the accuracy of flight path optimization, collision avoidance, and route adjustment, while IoT enables continuous data flow and remote monitoring of drone performance and environmental conditions. The potential for large-scale urban drone deployment is significant, as these technologies pave the way widespread using in delivery services, emergency response, and infrastructure monitoring. By improving AI model, drones can make more precise decisions, adapting to dynamic urban environments. Additionally, advancement in drone battery life could, coupled with improved charging infrastructure like solar integration and IoT-based monitoring, will extend operational time and reduce downtime. Expanding this framework for global drone traffic management could lead to the could lead to standardized protocols and systems for safe, scalable, and efficient drone operations worldwide, promoting a new era of urban mobility. Thank you so much.
Do you hear me, Dr. Mohammed?
Yes, sir. Yes, sir.
You say that you are using two network in order to save energy. Is this
Yes,
true,
sir.
or just to increase reliability or something like that?
We
How
are actually
how to
considered.
save energy using two network?
Okay, okay. We actually consider here various kind of scenarios. So we use energy management for shortest path optimization algorithm for the drone reach the goal in short way. So this can help for energy optimizes, and also we integrate solar energy or solar platform integrate with drone, so it also can help the energy management.
This is a logic, but I
Yes, sir.
read in your papers that you are using two different network in order to save energy. Is it
Yes,
true
sir.
or not? How
Yes, sir.
how
Yes,
not
sir.
how network save energy?
Sir, sorry, I couldn't hear it.
You, for example, you say that you will using GSM and the ordinary web in order to save energy.
Yes, sir. Yes, sir.
How to save energy by using these two communication network?
Okay, okay. So these two helps to save our energy management and so for energy, but for network we we are using some algorithms. So that's the way we are helping to manage our energy and improve the overall performance of the drone.
But this is has effect on energy. Mm. Okay.
Yes, sir. In future, we have to do a lot of case study and also apply some of others case study will, so that it will be more enhancement in future. So this
Okay.
technology is it's very very new, so that's why we couldn't get the enough or enough get time of data for or enough type of case study for this research.
Okay, thank you for your presentation, Mr. Muhammad. I wish you all the best, inshallah, to complete your thesis and make it deployed, inshallah, in the reality. Thank you very much.
Thank you so much, sir, for the
By the way,
opportunity.
you have here certificate. I don't know who can receive it that you attend the conference. Yeah.
Oh, don't worry, sir. Our dedicated member are just reach in the conference. They will absolutely collect there.
Okay, thank you very much.
Thank you, sir.